So in the last video, we created all the subnets, public subnet, private subnet hub, and private subnet data, right? And I said that these subnets are basically the same. We just gave it different names. So in this particular video, right, in this particular part of the project, we'll be able to dive into what exactly makes it public, private, and so on. So now we'll be creating our route tables. Our route tables, right? And creating routes. So I'll show you what that means. Okay, let's go to, okay, my naming convention. You can see that what we even have next. Let me split my screen so that I don't need to be going back and forth like I was doing earlier. Okay, yeah. So we want to create our route table, the public route table. So here's the name, copy the name, and then if you look at this left hand side here, you would see route tables here. Yeah, route tables. Yeah, and there's no route tables definitely. So we want to create our route table. So this will paste the name of the route table. It's a public route table. Then we'll select our VPC, the dev VPC, and we click create. Right, successful. So let's create for the private. So I would copy the naming convention here and we'll paste the name here, and I'll select my VPC, dev VPC, and click create. Right. All right. So let me expand this because I want to explain and show you some few things. So in the route tables here now, we've created two route tables, public and private. Note that they are the same thing, it's just the name that we give to it that is different. So what exactly differentiates it and how do we do that? So we need to okay, click on the public subnet here and drag this up a bit. Here we have routes, right, and subnet associations. So in this route, if you look at it, the only thing that we have here is the CIDR block of the VPC, and the target is local. Local means the access is only within the VPC, can't go outside. And the public subnet is meant to have access to the internet by the internet gateway that we created earlier. So what do? We edit, to click on edit route, and then we add route here. In this place, we click on this one. This means when you send it in 0.0.0/0, it means internet. It means that you are giving access, you want to access the internet, or you want anything in the internet to access. But in this case, right, our destination is the internet. We want to access the internet. And our target, right? Target here will be our internet gateway. Like we said earlier, the internet gateway was attached to the VPC so that the VPC can communicate with the internet. But this is exactly how we now do it, by creating a route table and then having a destination of internet, specifying it, and then attaching our internet gateway. So if you click here now, you will see the internet gateway we created earlier. Attach it to it and save your changes. So now this route table is public. So what makes a route table public? A route table is public because it is associated with a route. Is a route here that routes traffic to the internet through the internet gateway. That's what makes a route table public, basically, simple terms. So quickly, we need to work. Okay, for our private subnet, we need something, because we need to also attach something to it, and attaching to it is the NAT gateway. So the NAT gateway, just like the copying name convention, just like the internet gateway, in this case now, it gives access, or it allows okay, saying something. It allows the resources. I'm trying to navigate to the diagram so that I can explain. Okay, so this is the NAT gateway here, right? The internet gateway is here. The NAT gateway is going to be in the public subnet, but the purpose of it is that the same way this gives access to every resource here, our NAT gateway, we don't want people to access, our users to access, to have a direct access to this private subnet. That's why we want it to be private. We want everything there to be private. We don't want anybody outside to access it directly. If they're going to access it, they have to pass through the internet gateway, then the load balancer. So what they are interfacing with the load balancer, they are not interfacing with our web servers. So, but the way because in these web servers now, we'll be actually hosting our application and we'll be installing and doing we'll be doing some Linux administrative tasks here, like installing things, and the like downloading stuff. So for us to download some things, right, or even most things, the source of those things is in the internet. And because of that, we need access to the internet, even though we are in a private subnet. And the way we can do this securely is through the NAT gateway. So the NAT gateway is attached to the private route table I've just created, right? And then it allows the resources in the private subnet to be able to have secure access to the internet, right? No, these users cannot reach here. They stop at the load balancer and load balancer routes traffic. We'll get to see all of this as we keep on moving on. But that's just that's the way it works basically. So for this one, we are creating a NAT gateway, and then you go down, you see NAT gateway here. So our NAT gateway, you create NAT gateway here, and then give it a name. Copy the name already. I paste it, and then choosing the zonal part, because if you choose a regional, it would basically I would explain that, right? Let's keep on going. Just choose zonal, and for your subnet, it's going to be in the public subnet, like we saw in the diagram. So you can choose easy one or public or two. I'll just go with one. Any of it goes. So it will basically a NAT gateway needs an allocation of an elastic IP. So we need to allocate one. Just click on allocate, and just allocated one to it. Right. So now we can click on create NAT gateway. Yeah, that's been created. So if you click on the NAT gateway here, you will see that it has been created. So we allocated an elastic IP to it. Maybe if you click on elastic IP here, you should see one elastic IP. All right. It's loading. You should see one elastic IP. Okay. So if you notice when we're creating our NAT gateway, I chose zone instead of regional, right? And the reason is because if I had chosen regional, it was going to have our NAT gateway in the two availability zones. So we are going to basically have two elastic IP here, and that is AWS charges for elastic IP. So I'm trying to minimize cost. That is why I didn't do that, right? Yeah. So it has been created our NAT gateway. So we need to attach this NAT gateway to our private route table to actually make it private. So just like we did here to the internet gateway, click on route. Okay, there's something else that we've not done, right? But let's finish this route part of it. Click on route, edit route, and then click on routes here. You are going to have access to the internet, but securely via the NAT gateway. So click on the NAT gateway, and you see the NAT gateway I've created here, and you save changes basically. Yes. So actually, we are not actually done. There was something I missed that we need to now look at now. Let's start with the public subnet. So in this place, you see, we've edited our route here already, and we've included our internet gateway, like give access to the internet. But there was one more thing we need to, in this place, we see subnet association. We need to associate some subnet to have that access to what we've done already, right? So this is actually what makes a subnet public or private. If you don't associate it, it can't have those permissions. So for the public subnet, we just click on these two public subnets because it's these two subnets that would have access directly to the internet via the internet gateway, and the remaining is going to be through the private route table. So to private, click on, we've already done the route, that is the NAT gateway, subnet association, edit subnet, and then you click on this. Even though this is application data, they are all private. So we save association. So now, right, our public subnet, that we have two public subnet and four private subnet. Our public subnet is now public indeed, right? Why? Because it is associated with a route table that routes traffic. In this case, that's it. That route traffic to the internet through the internet, to the NAT gateway, I mean. And this is public because it is associated with a route table. Our public subnet, if I go to subnet here, we'll see what I mean. Sorry. Our public subnet is now public because it's associated with a route table. This is a route table here. This is a route table here. And this route table has a route. It routes traffic to the internet, which you can see here, via the internet gateway. So that is the difference between a public subnet and a private subnet. So we'll continue in the next video as we create more resources.